In fact, what's really cool about this is pretty much all of this you saw in grade 10, but when you did it in grade 10, you were so probably overwhelmed with how hard the factoring and knew it was, is some of this was very difficult for you in grade 10, and we're going to just revisit it and see how it's actually sort of grade 12 material, but it was something you could do in grade 10, but now we're going to actually make use of it a lot more than you did back then. And we're going to revisit a few other questions from grade 10 that really aren't grade 12 questions, but just kind of for fun, because I think it's interesting how far you've come in your algebra skills at this point compared to grade 10, and how at the time a lot of you, not all of you, some of you probably got it, but a lot of you would have found these to be quite challenging questions, not these two in particular, but the ones that are coming. But now you probably like, okay, yeah, now I get it. Now I really see what they're talking about. It's neat to look back and remind yourself that like learning comes in stages, and challenging yourself is good, but you don't always have to be perfect at everything. But then when you look back later on, all of a sudden you're like, wow, that's a lot easier than I remember it being. I remember it being really hard, and now I get it. So that's kind of a neat part to all of this. So these two, what do you notice about them? What do you notice about the first one? Yeah, it's missing some terms. It's only 3. So we call that a trinomial. That's important. Not quite, but there's something about it. But like, so it's missing some terms, so we need ghost terms. What degree? The first one? Degree 4, right? The other one is degree 3. So these are higher degree polynomials. These are not grade 10 questions. These are grade 12 questions. This is what we've been doing. But we can solve both of these with methods we learned in grade 10. And as I said, in fact, you may have seen questions just like this in grade 10. And we do that just to push your understanding of factoring a little bit further. If you took grade 10 at this school, other schools don't necessarily do questions like these because they are challenging. But we like to push your abilities a little bit. So does anybody notice anything else about this one?
Like we could start with like factoring the x squared minus 12.
Maybe. What if I did this? What if it looked like this? And what is it? I don't think we can do that because it's not even equal to 0, so we can't shift things around. Yeah.
So x squared and then bracket squared plus x squared negative 12, and then less y equals x squared, and then it will be y squared plus y.
Yes, we could do that. We don't have to sub in though, but that's exactly right. That's how we're going to do it. What if I wrote it like this though? Can you factor that? This is simple, right? This is just a simple trinomial. This is the same kind of question, and if you remember back from grade 10, it turns out that as long as you've got a constant and this exponent is double that exponent, you can factor these like a simple trinomial. So this is double that, and then I have a constant. So this is actually a simple trinomial. If you were doing it with factor theorem, you'd have to hunt for a factor, do synthetic division, and then you'd have a cubic. You'd have to use ghost terms, like I said. Then you'd have a cubic. You'd have to hunt for another factor. Then you'd have to divide again, and it would be a lot more work than if we just go like this. So, hold on. Let me do it like this first. X squared plus x minus 12 would be x plus 4, x minus 3, right? Everybody's okay with that? So then isn't this one just x squared plus 4, x squared minus 3? But it has the same relationship. Whenever the exponent is doubled, and then you have a constant, you can use that same technique. And that's done. Like, that's a lot faster than synthetic division. You could do it with factor theorem and synthetic division or whatever. You could use long division, I guess, if you really wanted to. Yeah, it would work. Okay. If you got a question, but this one should be one that you I think would be able to get if that popped up on a test. That one is easy to get. B is a little bit quirkier, a little bit trickier. Is everybody okay with this? What about B? What about B? Anybody recognize anything about it? So it's degree 3. So it's a higher degree, not a grade 10 question per se. So there's this thing that you do in grade 10, and you do it for a day, and it's on the test, it's on the quiz, but it doesn't come up again after that. It doesn't come up in the problem solving. It doesn't come up in the next unit when you're solving and stuff like that. We do it for a day, and it's very strange at first. People struggle with it, and but you get it eventually. But then we don't use it. So why do we use it? Because it does come back up in grade 12 in a couple of little areas. And it's called factor by grouping. So you may still not remember how to do it, but do you remember that term, factor by grouping? So yes, so factor by grouping works like this. It only works in special situations. And again, if you recognize it, it's a lot less work than doing the synthetic, or than doing factor theorem and synthetic division and all that stuff. So once in a while, now we're not doing it enough that we're going to give you tricky ones of these, but it could be that you would have to reorder the terms, okay? But we're not going to worry about that too much. We're going to give you some simpler ones. So the first step is I break it up into 2 groups of 2. So I break them up into pairs, and I common factor each pair. So let's do that. What's the common factor in the first pair? X squared. And what am I left with? It should be x minus 1, I believe. And then this is the tricky part, is I have to factor the next part in such a way that it has the exact same bracket of x minus 1. So it's not quite just common factoring. In grade 9, when you learn to common factor, there's this question that often comes up and says, do you factor out the negative? And it's a difficult question for a teacher to ask because there's no rule about that. But you factor out the negative if it's convenient, is really what it's all about. There's this interesting thing that happens to you when you're in high school math, is high school math is so much about following rules. There's rules that guide everything. But real math isn't really about that. It's about doing what's convenient and taking an expression and changing it in a way that's useful. That's what it's really about. But we learn all the skills required to do those kinds of things. So in this case, and this is like, this reminds me of completing the square. Completing the square has these little, strange little steps in it where you factor something out and you multiply by something, and it's not based on a rule, it's based on convenience. Anyway, this is sort of similar to me. So what am I going to common factor out to make this work? I got to take out a negative 4 so that I get a positive x minus 1. And if those 2 brackets are not the same, it's not going to work. So in this case, you have to common factor out the negative. And then there's one more step. And again, this is a step that in grade 10, when you're first learning this, people struggle with it. But at this point, you probably won't find it too bad. You just write the first bracket. And then you write what's left, the coefficients of the brackets, which is, well, not quite coefficients, but you know what I mean. The x squared minus 4, the thing that was out in front of the brackets. And then we're done, right? We're done, right, Sabia? Done? I don't think so. No, because there's 2 of them. No, it's just x minus 1.
Oh, right.
Yeah. Isaac. Why in the world would you do that? So we still have a difference of squares. I think we saw this yesterday. Be careful. Always look at the end. And there's one last step here. And this would be interesting if you went back and did the factor, like did this question by factor theorem. And there's your 3 factors that you could find. It wouldn't be too hard, but you would do synthetic division at least once, and then, you know, it would be a different kind of a question. But look at how easy that was, right? Way faster, way easier. These little tricks of the trade will help you with your test, save you time. If you miss them all, it's going to take you a lot longer to get it done. So keep that in mind. And there's some practice that I'm going to hand out today that'll let you practice these kinds of questions. Okay? Everybody good with those two? We got one more. And this one is not as tricky, I don't think. I think it's more obvious. But again, it's kind of just pointing out a little time saver. I always start questions by making observations, and I think you do this too. You might not be aware that you're doing it, but you're like looking at the details of the question. You might be looking at things, is there any terms missing? Like, does it have every exponent? You're hopefully looking for the degree because that's really important. In some cases, not when we're factoring, but in some cases you might be looking at the sign of the leading coefficient. If the sign of the leading coefficient was negative, maybe you don't want it to be negative. Maybe you want to do something about that. I don't know, but Samir, you had your hand up. What did you notice? Common factor in x, it's missing the constant term. What if somebody said, oh, I'll do synthetic division and I'll put a ghost term in for the constant? That would work. You could do that. But wouldn't it be easier to turn this degree 4 into a degree 3 with one step? Because it's so much less work. Okay, and one thing I want to point out is be careful, don't lose the x, either in this unit or in the next unit with this comes back up, or anytime obviously in the course for whatever reason. Sometimes people think the x isn't important and they lose it, but we saw when we took up that quiz that it is super important. It's actually an x-intercept and the y-intercept right there kind of thing, so don't lose that. I don't know. I don't think so. It does kind of look like you might be able to, and that would be interesting if you could. And you can go ahead and try, but I don't think that will work because I don't think I can turn 27 and 36 into like a 2 kind of thing. But you could try it. I wasn't thinking that. I think the next part is just factor theorem. This is a bit of a tricky factor theorem question. Why? Anybody know why? Or it might be tricky. What if like 36 has a lot of factors in it? Remember how you look at the constant for what to try? 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4, 6 and negative 6, 9 and negative 9, 12 and negative 12. Imagine it went all the way to negative 12. We wouldn't do that to you, but imagine, right? That would be a lot. So anyway, to save us a bit of time, because we've already done this, I believe f at, I think I lost my notes here, negative 3, that's what I thought. F at negative 3. So you would try all of these, and you might, and even getting to negative 3, you've tried 1 and negative 1, 2 and negative 2, and 3 probably, and it took us to negative 3 to find a factor. So x plus 3, and I'm going to show you this little trick again in case, is anybody, you know that little trick that I showed you? Is anybody using that? Yeah, one. The little trick instead of doing the synthetic division in the last step. Okay, a couple of people are kind of using it or at least thinking about it. So I'm going to show you one more time in case it clicks with anybody. But remember, you don't have to do this. You could do synthetic division with your x plus 3. But the trick goes like this, and it has to do with looking back at this and how this times this has to give me back that. So it goes like this. X times something is going to give me 2x cubed. So what is that something? This part's supposed to be easy. 2x squared. X, no, sorry, 3 times something is giving me negative 36. So that should be good, negative 12. Those parts are supposed to be easy. It's that middle term that's a little bit harder. So if you just want to watch, when I do 3 times 2x squared, I get 6x squared, but I want 1x squared. So this times this has to give me negative 5x squared. So I get 6x squared minus 5x squared. So x times something has to equal negative 5x squared. And so it is negative 5x. And I'm going to show you again. 3 times 2x squared is 6x squared. And x times negative 5x is negative 5x squared. And 6x squared minus 5x squared is 1x squared. So you're always looking back at what you were multiplying to. But don't force that one because it's a lot of mental math. But it's nice, and again, it's a time saver if it works for you. Any questions about that? And it's not done because we can factor that last little bit. Whoop. Four minus 4 and plus 3. Any questions about that? So look for a common factor of an x. Oh, good call. Just like I said for you not to do, and then I did it. See how easy it is? Very nice. It's always a good idea when you finish a question to look back at the original, look back through steps, look for little things like that. And what was I going to say? Look for a common factor of an x. That one shouldn't be too tricky. Look for that, though, when you first start a question. And then the other two time savers that we looked at here were those two. And so think about that. Factor by grouping is a really big one. This one probably should be pretty straightforward.
When you say factor by grouping, isn't it also like factor x from like the first 3 terms? And then
no, you can't factor by grouping into 3 terms and then 1 extra term. But sometimes it usually would work if you flip 2 of the terms around, and then it would still work. So if the 2 middle terms were flipped, probably still could have done it that way. But it's 2 and 2.
So factor by grouping has to be 2 and 2. Right?
Yeah.
Could it also be 6?
Yes. We won't see that, but certainly you could do something like that. Yeah. Yeah. Really what you're doing at this stage is you're taking a common factor of this and this out. So it's like 3x squared minus 3 times 4, except it's not 3, it's like a bracket. So really what you're doing is common factoring there. But it's easier, honestly, to just think of it as its own special thing, factor by grouping. All right, I'm going to put up 4 more questions, and I'm going to talk. Oh, where did they go? Did I pass them? Oh, no, they're not here. I am going to put up 4 more questions. Give me a second. And I'm going to talk about them briefly, and then I'm going to let you try them and put the solutions up after. I'm not going to do all of them in front of you because we don't need to, quite frankly. And again, it's just because they're from grade 10, so they're not probably questions that will come up, but I think they're interesting. And here they are. So I'm going to look at these 2 first, and you can write them down after. You might want to just watch. But does anybody notice for D and kind of for E, like, do you notice anything about them? What do you think?
We could do the x squared minus, we could do like x minus 1 whole square minus x plus 1 whole square. Is the polynomial. We can evaluate it. It's just going to be x minus 4 plus.
Yeah, so it's a difference of squares, in other words.
Yeah.
Very good. This is like a difference of squares, and you would have seen this in grade 10. But these are all quadratics. They're not higher degree, so they're probably not going to come up for us. But still, it's interesting to revisit, just because back in the day you might not have noticed, but now you will. So this is a difference of squares, but the binomial is the square, but it's like this. It's like a squared minus b squared, but this bracket is my a, and this bracket, whoops, is my b. But I can factor it the same way. A plus b, a minus b. And what about this one? Yeah, it's a difference of squares as well, but it's got fractions, so some people aren't so sure about that. But here's your reminder. This is a good thing to know. The square root of m over n is equal to the square root of m over the square root of n. So when you do this one, you just take the square root of kind of all the different parts, but you continue to write it as a fraction. Okay? And then what about, oh gosh, what about f? We're going to solve f right now. What is f? Not factorable. Thank you very much. It's not factorable. So yesterday we did a sum of cubes and a difference of cubes, and they both work. And then we saw a difference of squares. We've seen those. Those work. Sum of squares does not work. People are like, oh, I know this one. It's super easy. It's x plus 7 squared. Oh my gosh. You suck a little life out of me every time I have to see somebody do something like that, right? When I expand this, I get x plus 7 times x plus 7, and that is x squared plus 14x plus 49. There's always that middle term in there. And so this is not factorable. And actually what happens in this course or in grade 12 is we still get some people expand that instead of to this. So you really need to know how to expand binomials that are squared properly, but we need to know that this is not factorable. Okay? And then what about G? It's kind of a regular quadratic, and if I wrote this like a squared plus 4a minus 21 and factored it like that, like a simple trinomial, except my a is x plus 3. If you want to revisit those from grade 10, you could try those. Like I said, I'm going to leave them up here, and I'll put the solutions up after. Otherwise, you can get started on the practice or do some review or something like that. Finish your learning. Oops, sorry.